Another example for Euler's method. So here we have dy dt is equal to y times 3 minus y. And our initial condition is a little different this time. It's y at t equals 2 equals 1. Then our step size here is delta t is 0.1. So we have f of t comma y. Well, that's just y times 3 minus y. We have our t sub 0. Well, that's right there. It's 2. We have our y sub 0. Well, that's right there. It's 1. And now we get started. So we have t sub 0 equals 2. If I want to get to t sub 1, I add delta t to t sub 0. Delta t is 0.1, so it's going to increment to 2.1. Right, t sub 2 is 2.2. T sub 3 is 2.3. T sub 4 is 2.4, and so on. Right, the worst ones to calculate are the y's. So we have y sub 0. Well, that's equal to 1. Now y sub 1, so let's go ahead and simplify this in the first one. So that's y sub 0 plus delta t times f of x sub 0 comma y, t sub 0. T sub 0 comma y sub 0. Well, that ends up being, there are no t's on the right-hand side here, so it ends up being y naught plus 0.1 and times y sub 0 times 3 minus y sub 0. These numbers get tedious almost immediately. So here, y sub 0, okay, well that one is 1 plus 0.1 times 1 times 3 minus 1. Okay, I can actually do that one in my head, but I will look at my notes. That ends up being 1.2 is y sub 1. But then y sub 2, well, that's going to be kind of copying this formula and incrementing all the subscripts. It's y sub 1 plus 0.1 times y sub 1 times 3 minus y sub 1. Okay, well, that ends up being 1.2 plus 0.1 times 1.2 times 3 minus 1.2. And I can't do that one in my head. That one ends up being 1.416. And again, so let's do a couple more. Y sub 3 is y sub 2 plus 0.1 times y sub 2 times 3 minus y sub 2. All right, so 1.416 plus 0.1 times 1.416 times 3 minus 1.416. Okay, that ends up being, I think approximately at this point, 1.64029. And let's do one more. So y sub 4 is y sub 3 plus 0.1 times y sub 3, 3 minus y sub 3. I think this will fit on one line, so 1.64029 plus 0.1 times 1.64029 times 3 minus 1.64029. And apparently, if you do that one, that's 1.86333. All right, so just keep doing it over and over again. If you were to graph this one, this is the t-axis, that's the y-axis. It ends up looking, let's see if I can get this approximately to scale. So that's 2, that's 1. So this is our initial condition here. That's t sub 0. This is y sub 0. And if you keep doing this further and further and further, so let's see, 1, 2, 3, it will end up doing something like this. It ends up asymptoting to 3. So all you can really tell in this one, right, we started at 1, then we got to 1.2, then 1.416, then 1.64, then 1.86. So it looks like it's sped up for a while. The difference between here and here isn't quite 0.2. Oh no, it's a little more. Sorry about that. Yeah. So this is the long-term behavior, and it's really just, over and over and over again. Computers are very good for this sort of thing. And by the way, so there are links on my personal website. You can actually have Wolfram Alpha calculate Euler's method for you. You can give it the ODE, the initial condition, and the step size, and it will actually calculate it for you, and it'll make a table, and you can actually check your work if you're doing your homework. So yeah, go ahead and check that out. But that's the end.